Cross-origin resource sharing and the same origin policy are really the foundations for client-side attacks. And it all stems from the fact that your credentials are now saved by the browsers in cookies, which can reuse them at a later date. But the issue is that websites can now make requests on your behalf using your stored cookies, and they could potentially do things like take your API keys by using your credentials to fetch them from a third-party website. And to prevent this, browsers created the same origin policy, which basically restricts how websites can interact with each other, and it's a series of rules which dictates what websites can and can't do with each other. So before we jump into some live examples, I just want to talk about what the same origin policy actually is. So the first thing you need to understand is that the same origin policy is a browser-side defense. It's not implemented by websites, it's a rule that is forced upon them by browsers. So how it basically works is that browsers will send this origin header with each request, and if the browser decides that the request doesn't match the rules, it's a cross-origin request which it doesn't allow, it just won't return the response to the website that actually made the request. So the rules that it has are actually quite strict, and the main thing is that basically if you're making a request cross-domain, then generally it will not be allowed. So what is defined by an origin is if the website has the same protocol and if it has the same port and the same domain. That means it's on the same origin. Anything else, like you see in these examples, gets rejected. If the protocol is different, if it's a different port, or if it's a subdomain or a different domain, it doesn't get differentiated by the browser if it's a subdomain. And certain resources though are kind of exempt from this rule, and the main ones are JavaScript files, which you can import from like CDNs and different websites. You can import images and iframes. Those are the main kind of three, and then all the other things you see here. Kind of more static resources and dynamic resources generally fall under the cross-origin policy. So obviously you might want to make requests cross-origin. As a developer, if you have, for example, an API hosted on some other subdomain, then it makes sense that you'd want to make cross-origin requests with credentials to that domain in order to fetch the user's resources. So what browsers came up with is these headers, which allow you to dictate and kind of bend the same origin policy rules to sort of fit the framework you're working with. And the first header, which I'm going to talk about, is the access control allow origin header, which means that if you return this in the response, the browser will allow whatever origin you've put in here, or if you use this wildcard, this asterisk here, then it will allow every origin. So keep in mind here that the return response can only have one header, and it can only send one origin. So you can either allow one origin or allow every origin, which doesn't make a lot of sense to me, but it's just the way it was programmed. So it does put developers who need to allow two origins or more into a bit of a sticky position, which can lead to some vulnerabilities that we'll talk about later. But the next important header is this one right here, which is the access control allow credentials header. And this one tells the browser if the third-party website is allowed to include the client's credentials with the request. So if this is set to true, you can append cookies onto the request. If it's set to false, then you can't. And those two are the main ones. There's loads more headers. There's loads more cross-origin headers, but most of them, to be honest, are not that important, especially from a bug bounty context. We just want to focus on those two, and if those two headers are misconfigured, then we can lead to CORS misconfiguration vulnerabilities, which we can then later exploit, and that I will showcase now in the demo example. So here I just have a HTML website running, and you can see its source code here, and a PHP website, and its source code is somewhere in here. Yeah, source code is in here as well. So the PHP website is hosted on actual domain, and it will be the gatekeeper of the resources. It'll be like the first party website, and this HTML website will serve as the sort of third party or attacker's website in this context. So you can see the two headers here: access control allow origin, and the access control allow credentials origin header here. So if I just come up here and set this to like, God's sakes, and set this to like secret.com, so something that's an invalid origin in this case, and I just save that there, and I go over here and try and make this cross origin request, the browser should decide that it's that this request is not allowed. In this case, yeah, it'll tell me that the same origin policy has been violated and that it will not show me the response to that request. So I might as well just show it to you sort of in action. So in this case, as you can see, I've refreshed the page, and my browser has now made this request, and you can see it's appended this origin header here, right? So as soon as I let that go, yeah, the browser will deny that request because the origin is null. It's null because I'm sending it from my computer, and in this case, it does violate the same origin policy. Well, let's modify that so it doesn't. So we'll go into here. Yeah, so here now I've set the origin to be the wildcard origin, and the request has now gone through. So that's how we can make cross origin requests, and that's basically how developers will program them. So the like access control allow credentials header works the exact same way with the cookies and stuff. But what is interesting to note is that if you set this wildcard here and you set this to true, then the browser will not allow you to send credentials. And this is just a defense mechanism, because if you basically did this, it would allow any website to send your cookies, which browser decided was not a good idea either. So this is blocked. And if you want a website to be able to send cookies to you, you have to mention it specifically. So you have to mention it up here. Like you have to say like secret.com. In this case, the secret.com will be able to send cookies to my platform. Again, this puts developers in a tricky position if they want to allow two origins or more than two origins. So that's really where the vulnerabilities exist, and we're going to move on to them soon. So the first and most common vulnerability is basically when the website copies the origin from the request directly into the access control allow origin header. So I'll show you that now, right? So I've set this to run, and now if we refresh this again, right, so we have this request. I'll send this to the repeater just because we can have a look at this. And in this case, I don't have the cookies appended, but if we send our origin in, say like, right, so I've sent the origin in, and as you can see, it was basically directly echoed onto the header. So basically, no matter what origin we could send here, we could set like www.test.com, and it'll just echo it directly like that. Why would a developer do that? Well, again, if they want to allow more than one origin, this is the only way to do it. They have to add a check and basically make this header dynamic. You have to dynamically set this at runtime. And this isn't really seen anymore, but back then, basically developers kind of just put every origin header, which would basically completely bypass the same origin policy. So if you put this and this together, then basically any website on the planet can send a credential request to your website. And if this was like sensitive here, in this case I haven't appended the cookie, so it didn't return the API key to me. But if this was sensitive data here, then obviously basically anyone could fetch it. If you clicked on like one dodgy link, someone could just steal your credentials. So that's why it's important to watch out when setting these headers. And the second vulnerability basically occurs if the regex used by the developers to set the origin is sort of too loose or it's faulty. So again, if a developer wants to set more than two origins, then he has to make that header dynamic. And a lot of developers now use regex for. So they'll check basically if, for example, if this was like example.com, they'll check if this is a so what developers will do is they'll check if this is an origin of the desired platform. So in this case, example.com. And if it is, they'll basically append it directly onto the access control allow origin header. So I think in this case, I've added to the main website. So we'll just copy that and have a look at the origin here. And if we paste that in here, oops. Yeah, if you paste that in here, you'll see that the regex was triggered and it directly allowed our origin in. So that's definitely one way that a developer could allow more than one origins, especially if they want to allow all subdomains on their platform. They could use regex to do it. But potentially this regex is weak, and you can use a lot of URL bypasses here. So you could try and like mask this as a domain of your website and then see if it passes the validation. In this case, it will, because this is deliberately vulnerable. And you could even try like me breaking this up somehow, like doing something like this, like registering that domain here. In that case, that won't work. But yeah, there's a lot of like techniques you could use to try and bypass it like that. And the way you can detect this is if you see two domains, if you see two subdomains, and both of them basically get echoed into here, that means the developer is probably using regex to basically echo this into the access control allow origin header. So you could look for bypasses there. And again, if you manage to bypass it, you could basically leak anyone's credentials by them just clicking on the link. So it is also quite a high impact vulnerability. And the final vulnerability I want to showcase is this null access control allow origin null header. And this doesn't seem like a vulnerability setting this to null, but as you saw with my own computer, the browser will set this to null if it's in like a sandboxed environment. So if you're running it from this like file, or if you're running it from a sandboxed iframe. And in this case, so if I go here and I allow this iframe to run like this, so this will actually send in the null header as well, because it's running from like the source document. It's a bit confusing, but that's basically the script that will run from this iframe, and this will allow us to send the null origin header, and it will also allow us to send the credentials if it has that inside. But first of all, before we do that, I'll just actually set my cookies so we can see this running. I'll visit this login.php page, which should log me in. And now if I refresh the website, right, so now if I refresh the page, you'll see that this API key will now be taken from the other website, and we managed to basically bypass the access control allow origin header there. And this kind of this header here could be left in by mistake. Maybe this was like a deprecated feature and they just said, we'll put a null for now, we'll use this as a template. So that could also lead to a vulnerability, which could lead to leaking user data. So now that I've shown you those vulnerabilities, let's just have a look at some actual bug bounty reports here. So just full screen now, so we'll have a better view on it. So yeah, so this person here basically sent the origin in the request, and he noticed that it got echoed in the access control. Let me make that a bit straighter. He basically just noticed that it got echoed there, and that meant that again, any website could make a request there. So there's absolutely no protection for the website, and especially since they used the access control allow credentials. Yeah, so especially since they were using the access control allow credentials header here, which meant that any website could make a credential request. So depending on what data was being stored there, this could be either a high impact vulnerability or a no impact vulnerability. And in this case, I think it was actually sensitive data stored there, but this was a vulnerability disclosure program. So sadly, this hacker did not get any money for this, but still an interesting vulnerability nonetheless. And now we'll look at this one, which was actually inside a bug bounty program. So, pretty much same situation here. The hacker visited a vulnerable URL here, and then noticed that the origin was echoed in the access control lab origin header. Yes, that's pretty much the main vulnerability. Is just this thing getting echoed, and that allowed the person to basically steal credentials. And I don't know how much he got for this, but I imagine as medium, so probably wasn't too sensitive there. That's the main two bug bounty reports I was able to find. Honestly, this is not a very common vulnerability. Probably won't find it very often, but this is really the entry point. The more advanced vulnerabilities like CSRF, which we will cover later, and it's basically built on the foundation of this rule here, same origin policy, except that this time it's used to perform requests that change actions. So if you notice here, the same origin policy blocks us from seeing the response, which is important if, for example, the response is here like an API key. But if the request actually makes changes on the user's account, well, then it doesn't matter if we can't see the response because the changes happened anyway. So in this case, the same origin policy doesn't protect from CSRF, which means cross-site request forgery. That's when you're able to make requests on behalf of another user and basically using their credentials. And there's a separate sort of line of defense for that, but we'll say that for the next video. And for now, that's the demo over. So if you enjoyed this video, please consider leaving a like and subscribing to the channel. You can also watch my previous video on prompt injection, which is how hackers were able to hack AIs and basically leak user data. Or you can watch my previous episode on reading HTML if you found some of the things that we covered in this video confusing, like the iframe tags and stuff. That video might help you a lot. And as always, thanks for watching and happy hunting.